show that the given function is a solution of the initial value problem. So we're given the function y is equal to 5 times e to the power of 2x plus x. We're also given y at 0 is equal to 5. Well, what exactly does this mean? Well, this means that when x is equal to 0, y is equal to 5. And we're also given this differential equation. There are two steps. The first step is to plug x is equal to 0 into our function and see if y is indeed 5. So let's go ahead and do that. So y is equal to 5 times e to the power of 2 times x, and x is 0, plus x, and x is also 0 here. This is going to be equal to 5 times e to the power of 0. And what is e to the power of 0? Well, it's 1. So 5 times 1 gives you 5, and indeed, y is 5. So the first step is finished. The second step is to plug y is equal to all of this into our differential equation. So we see here, that's y, right? We can plug y into there, and we also need to find y prime, and we also plug it into the equation. And if the left-hand side is the same as the right-hand side, then our function is indeed a solution to the initial value problem. Let's first find y prime. So what is the derivative of y? Well, the derivative of y is d over dx of what? 5 times e to the power of 2x plus x. This is equal to 5 times the derivative of e to the power of 2x is going to be 2 times e to the power of 2x plus 1. So what do we get here? That's 10 times e to the power of 2x plus 1. Let's plug everything into our differential equation. So here we have y prime, and y prime is 10 times e to the power of 2x plus 1. So we have y prime. Now, minus 2 times y. Let's see. Minus 2 times y, and y is all of this. So y is 5 times e to the power of 2x plus x. So that's the left-hand side. How about the right-hand side? The right-hand side is 1 minus 2x. We get 10 times e to the power of 2x plus 1 minus 10 times e to the power of 2x minus 2x is equal to 1 minus 2x. As you can see, these two are going to cancel out, and we are left with 1 minus 2x. Since the left-hand side is the same as the right-hand side, then the answer is yes, this function is our solution to the initial value problem. Let's do one more example, and feel free to pause the video and try this one yourself. So the problem says, show the given function is a solution of the initial value problem. And this is the function that we're talking about. We also have y at pi is equal to 0, and here is our differential equation. This here means that when t is equal to pi, then y will be equal to 0. And the first step is to plug t into our equation and see if y is indeed 0. Y is equal to negative t, we can write it as negative pi, times cosine of t. We can just say cosine of pi, minus pi. So what is cosine of pi? Well, remember it's negative 1. And this gives us pi minus pi, which is 0. And because y is indeed 0, we can move on to step 2. But let's say you solve for y and you don't get the same answer as this one, then you can just say that this function is not a solution to the initial value problem. But in this case, we do get y is equal to 0, so we can move on to the second step. The second step is to plug our function into the differential equation and see if the left-hand side is the same as the right-hand side. So here is the left-hand side and the right-hand side. And we want to show that both sides are the same. Now let's go ahead and find y prime. So y prime is the derivative, dy over dt, of this function, which is negative t times cosine of t minus t. We can split the derivative out, so d over dt of negative t times cos of t minus d over dt of t. And we can also bring this negative sign outside. So let's do that. this is equal to negative. And what's the derivative of t times cosine of t? Using the multiplication derivative, you get d over dt times t times cosine of t plus t times the derivative of cosine of t minus, and what is d over dt of t? That's 1. We get negative 1 times cosine of t plus t times negative sine of t minus 1. Negative cosine of t minus t times sine of t minus 1, which is negative cosine of t plus t sine of t minus 1. So y prime is equal to negative cosine of t plus t sine t minus 1. And let's plug it into the left-hand side. We have t times y prime. And what is y prime? Y prime is this. So negative cosine of t plus t sine of t minus 1. So we have a negative t cosine of t plus t squared sine of t minus t. And how about the right-hand side? Well, we plug in y. So y is negative t cosine of t minus t plus t squared sine t. And if you look at both sides, they are the same expression. This means that we verified step 2 and our function is indeed a solution to the initial value problem. And that's basically it for today. If you enjoyed this video and found it helpful, don't forget to share with your classmates and also subscribe if you haven't already.